All right, we are going to take our exponential functions and we are going to look at families of exponential functions, which just means we're going to move them around, just like we did all of our other functions so far. So we're going to start with this one on the left, the parent function. We've kind of looked at this one. We even already looked at this with some extra stuff going on here. So I've taken the a out of it. It's just b to the x. There's no a value out there. So just in general, an exponential function that doesn't have anything out in front other than a 1. We looked at this in terms of the fact that if there's a 1 out there, what does that mean? And if there's a 1 out there, remember that number in front, nothing else changing about this, that was our y-intercept. So we knew this was going to cross at 1. This was our common multiplier, so each step to the right, I'm going to multiply by 2. So if I put a 1 up here and make a little chart, like really quick graph over here, put in a 0 here, 2 to the 0 is 1. Should do this so that actually it's like an x and a y. And if I put in a 1, I get 2 to the first, which is 2. So I'm moving up, and right now it looks like a line, but it's not going to be a line, because if I put in a 2 in the power, it's going to be 2 squared, which is 4, or each step to the right, I'd multiply the y by 2, so now I'm at 4. If I go one more, 2 cubed, put a 3 up there, that's going to be 8. So at 3, I'm all the way up here at 8. And remember, we went backwards. If I put in a negative 1 in here, it makes that a fraction, so my output would be a half. So at negative 1, I'm really compressing, and my graph then shoots straight up like this. And so we've seen those before. That's just the generic exponential graph. Without doing anything else to it, it just goes through 1, and it goes up to the right. By this as your multiplier. So if that had been a 3 to the x, I would go increase by multipliers of 3. So it'd go from 1 to 3 to 9 and end up that way. So when we look over here at the second one, I'm now going to put something in front, but we haven't looked at this. This says a is less than 0, which means it's negative. So we haven't looked at any negatives in front, and all a negative does is it's a reflection. Just like it was with a parabola, if we put a negative in front of our x squared, our parabola went from a U shape opening up to a U shape opening down. So the same thing happens to this. It literally just makes all of my outputs negative. That's all it does. And it's a negative 1 in front, really. This should be written as negative 1 times 2 to the x. And so all of these values that we were getting for outputs, 1, 2, 4, 8, 1 half, they would just be multiplied by negative 1. So as I put in x and y values, if I put in 0, 2 to the 0 is 1, times negative 1 is negative 1. So it just literally reflects below. So I kind of give myself a little bit more room here. And if I put in 1, 2 to the first is 2, times negative 1 is negative 2. So I put in 1, I'm down here at negative 2 now. If I put in 2, 2 squared is 4, times 1 is negative 4. So literally the pattern is just the exact opposite. So when I put in negative 1, I get 1 half, but times negative 1 would be negative 1 half. So the graph itself, with that negative out in front, all it does is it is going to be a reflection of what the graph was originally. So if you kind of look at these side by side, I'm going to use a different color. This graph without a negative in front just look like this. And as soon as I put a negative in front, it acted as if there were a mirror here, and it reflected straight down. So anytime you see a negative in front, regardless of whether it's negative 1 or negative 2 or negative 3, any negative number in the front is going to reflect your exponential graph, this half pipe that we were talking about, this quick zooming up, it's going to be reflected down. So it's literally just a mirror image going down instead. All right, let's take a look at the next thing we can do. And this is one we've already actually done. We've been doing these stretches without calling them stretches. This little fancy notation out here is just saying this number in place of a is bigger than 1. So like we already graphed this together, 3 times 2 to the x. All that 3 does is it's a stretch, which means it's just going to make my graph, this 2 to the x graph that we've been talking about on the first two, it's just going to make it go up even faster. So that's what it means by stretch, is it's just going to pull it up even quicker than it was if it wasn't there. And if it were a negative 3 in front, like if I had negative 3 and 2 to the x, then it's going to just go down, reflected down, so that this could have two things happening. A negative is a reflection, it opens down, and the 3 makes it stretch. So again, if we want to graph this, I'm just going to graph this 2 to the x in blue. So that circled thing is what I'm going to graph first. That's what we already looked at, just so we kind of see what happens. And we put in a 3, I think we ended up at 8, we're at half. So that was our original parent function of 2 to the x. So I'm going to look at this whole thing now in purple. So I'm going to look at the whole equation, 3 times 2 to the x in purple. And again, I already know the general shape. It's positive 3, so I know it's going to go up in this nice half pipe shape. But I'm going to go ahead and do this. So I put a 0 in. 2 to the 0 is 1, and 1 times 3 is 3. So remember, just like we were doing last week, that becomes my y-intercept. So already I'm here instead of down here. If I put in a 1, 2 to the first is 2, but I have to multiply that by 3, so I get 6. So this goes from a 2 to a 6. So again, see how it's quickly rising. Put in a 2, 2 squared is 4, but I have to multiply by 3, 12. So these are still all being doubled. That's my doubling factor there, but they have a quicker rise, if you will. And if I put in -1, which everybody loves to do, that's 1/2. And 3 times 1/2 is 3/2, or 1.5. So at -1, I'd be right there. So what is happening is, as I draw this next to the blue one, you can just see it has the same half pipe shape. It's just going up at a quicker rate than it was before. So when this number in front is bigger than 1, it's just increasing faster, which is what we call a stretch. That's why we call it a stretch. It's like taking a string and pulling it up faster. And if it's positive, it shoots up. If it were a -3, it'd be the exact same thing, but it would be going down because the negative makes it a reflection. So what we haven't looked at is this idea of a compression or shrinking. And so shrinking is when this a value, this fancy notation, is just saying, hey, that's a fraction in there. And again, it could be a positive or negative fraction. The only difference, positive fractions are going to go this direction, and a negative fraction is going to go this direction. And a fraction is going to be the opposite of a stretch. So it's going to shrink it or compress it. So it's going to kind of flatten it out and squish it because multiplying by a fraction makes your numbers smaller. So again, I'm in blue. I'm just going to put in our parent function of 2 to the x. So this was our parent function. And it was at 1, and then we went to 2, and at 2 we were up at 4, and at 3 we were up at 8, and we were here at -1/2. So again, that was the general shape of it. So I'm going to switch now. And I'm going to graph this with green, and I'm going to make a table. Again, the reason I'm doing this all with 2 to the x, kind of get an idea of what the inputs were. If I put in a 0, 2 to the 0 is 1, times the third is a third. So now I'm way down here to start with. See, I'm already below it. If I put in a 1, 2 to the first is 2, times 2 times 1/3 is 2/3. So at 1, I'm at 2/3. I'm still not even to 1 yet. If I put in a 2, 2 squared is 4, 4 times the third is 4/3. So you can see that the ones with fractions aren't very good, and 4/3 is just a little over a third. And then if I bounce to the negative side, 2 to the negative first was a half, because it just makes it a fraction, and a half times the third is a sixth. So it's way down here. So it's just kind of hard to draw, but you can see that this thing is still increasing. It's just happening much slower. Still a half pipe. It just isn't going up quite as fast. So that's what happens when that's a fraction in the front. It's kind of the worst situation we would want to encounter because we don't enjoy fractions as much. And if it's negative, it would just bend down instead of bend up. All right, one more real situation to look at, and this is translations. We have seen these all year so far. It's your left, right, up, down. Nothing has changed. The thing inside of the parentheses with the x, so up here with the exponent, that's going to be your right and your left transformation, and it's the land opposite, so a minus moves it right, a positive moves it left, and this is your up down, and this is just straight away regular. I don't know why I wrote up. I meant to write UD for up down, but that's all right. This is your up and your down. Positive moves up, and a negative K would move it down, and this is the land opposite, so a negative will move it right and a positive will move it to the left, and that's a sharp L. So they say horizontal, that just means right, left. and vertical means up or down. So we already know what 2 to the x looks like because we've seen it a few times. And so again, in blue, I'm just going to dot what we already had for our 2 to the x function. It's the same exact points we've looked at about 4 times now. If I make sure I get these right, 3 is 8, and that was at a half. But now I've got 2 transformations happening, so I'm going to use some very specific colors for just so we know. So this thing is in the parentheses, so it's going to move it right or left, just like all of our other power functions and parabola, all those, same idea. It's in the parentheses with the x, it's the land opposite, so this is going to move it to the right 4 units. So all of these are going to go right 4. 1, 2, 3, 4. It's like a temporary holding place. 1, 2, 3, 4. Temporary holding place. 1, 2, 3, 4. 1, 2, 3, 4. All right, so see how all of these red dots moved? It's the same exact curve, it's just moved to the right. But I also have this part out here, which is your plus k business, and that's regular style, so the plus is up 5. So now I'm going to take all of my purple dots that went to the right 4, and I'll move these all up 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And remember, this line, it never crosses, so this line can move up 5 also. 1, 2, 3, 4. I'm just going to kind of put it in here as a dash so that I know I can't cross it. And then I'm going to take and draw my graph. So it would be down here like this. So it was the same shape as this blue one, but it moved to the right, and it moved to the right, and it moved up. And there's no A out front, so I don't have to worry about stretching it or anything. All right, last scenario, everything combined. Here's the nasty situation. So we have a stretch of 3. We are still going right 4, and we're still going up 5. But we have this extra stretch in here. So that's kind of a little bit of annoying. And so I'm going to kind of show you one approach. If you don't want to deal with using a graph that we already know, you can say, well, I'm making my own table, but I don't want to use my 0, 1, 2, 3s anymore. I'm going to start by going, what makes this 0? So if I put a 4 in there, 4 minus 4 is 0. 2 to the 0 is 1. 1 times 3 is 3. 3 plus 5 is 8. So that's like my starting point. I'm just going to go start over here at 4 to 8. That's already taking in all of my transformations. And I want these to be nice numbers, so I don't want this to be big numbers up here. So if a 4 makes it a 0, then if I put in a 5, 5 minus 4 is 1. 2 to the first is 1. Sorry, 2 to the first is 2. 2 times 3 is 6. 6 plus 5 is 11. So at 5, I'm all the way up here at 11. You can tell that I'm already going to be shooting off this page, so I'm going to go the opposite direction. I'm not going to put a 3 in. 3 minus 4 is negative 1. 2 to the negative 1 is a half. So I've got 3 halves plus 5. Well, 3 halves is 1 1/2. And 1 1/2 plus 5 is 6 1/2. So I go 3 and I go up 6 1/2. And I'm telling you that's about the best I'm going to do. I do know that up 5 means this little line is going to go 1, 2, 3, 4. I know I'm never going to cross this guy right here. And I now know, I already know the shape of this. It's the half pipe. So I've got enough points here to kind of go, all right, here's what my half pipe is going to look like, because I can't cross that. So that's why it's important to move this horizontal asymptote up so you know not to cross. There you go. That is it. This last one was a bit crazy. I'm going to ask you to look at some equations and just to identify what the transformations are at this point. So this is your stretch, or if it's negative, it's a reflection. Inside here is your right or left, and it's opposite of the sign. And out here at the back, just hanging out by itself, is your up or down. And it is just like the sign says, a positive is up and a negative is down. So that is your lesson on transformations for exponential functions.